Hello everyone. Now we'll discuss about research methodology and intellectual property rights. Module 1 important question. The first question is the state the objectives of research methodology. Okay, what is research? Research is a process of creating or formulating knowledge that does not yet exist. Thus, research is the art of scientific investigation. Okay, this is the process. What is research? Research is the process of creating and formulating the knowledge that does not yet exist. Okay, now we'll see about objectives of research methodology. There are like six objectives. You should remember these points, like solve important problems. Okay, the main goal is to solve the new and significant challenges where the outcome is unknown at the start. Okay, the first objectives of research methodology is to solve a new and significant challenges where the outcome is unknown at the beginning or the start. Okay, next objective is to find useful information, learn how to locate or use different types of information to address engineering. Okay, first we should find the useful information so that we can do search about the problem. Okay, so learn how to locate and use the different types of information to address engineering. Then third objective is to follow standards and best practice. Research helps avoid mistakes caused by ignoring engineering guidelines or standards. Clear communication of result is crucial for making the right decision. Okay, what is the main thing is for result communication. Okay, it is very important like that. See, research helps avoid mistake caused by ignoring engineering guidelines or standards. Clear communication of result is crucial for making the right decision. Okay, we should follow the standards and best practice. Okay, next one is fourth one is use scientific methods. Okay, in research we should use the scientific methods. We should apply the systematic and scientific approaches to answer unanswered questions. Okay, fifth one is we should create new knowledge, develop new ideas, theories, practical solutions rather than just achieving a specific result. We should develop a new ideas, theories, or practical solutions. The last objective is to learn from failures. Okay, even if the research doesn't succeed, understanding why it is failed adds valuable insights and helps to solve similar problems in the future. Okay, we should learn from the failure. Even if the research does not succeed also, we should understand why it is failed, and it adds the more knowledge. Okay, like valuable, so that we can do further, like in future research also we can apply it what we and all learned from the previous failure. Okay, these are the six objectives. What is first we should solve the important problem, and we should find the useful information. We should follow the standards and best practices, use scientific methods, and create new knowledge, learn from failures. Okay, this all are the objectives. Next question they might ask, the motivation in engineering research. They can club this both objectives and motivation, and they can ask this both for 6 marks question. Okay, these are the motivations in engineering research. What is motivation? Means motivation in engineering research comes from the mix of intrinsic and extrinsic factors. We'll see about intrinsic and extrinsic factor. Intrinsic motivation means passion, like why how you motivated, means like by yourself you motivated, means by passion for learning and solving challenging problems. Okay, then desire to contribute to meaningful advancement or solve real world problems, satisfaction in unsolved puzzles and achieving breakthroughs, helping society by improving lives through extrinsic motivation, that is external reward like achieving status, awards, or praise for scientific contribution, opportunities to make money through patents or funded projects. Okay, motivation from peers, mentors. Example, like if your friend join to do research and you also get motivated to do research field, so that is the extrinsic motivation. Mixed motivation means both intrinsic and extrinsic. It is aiming to advance what is currently possible. Okay, helping to solve global or local challenges through innovations, fulfilling cultural expectations or historical significance, desire to achieve more than peers or competitors. These are the motivation. Okay, in the motivation there are three. One is intrinsic, extrinsic, and the mixed motivators. Okay, now we'll see next question. Explain different types of research, give distinct example of each. First one is descriptive versus analytical research. Descriptive means it describe. Okay, to describe the current state or characteristics of phenomena without manipulating variables. Okay, descriptive research means to describe the current state or characteristics of the phenomena without manipulating variables. It includes comparative correlational methods, fact-finding inquiries. It focuses on presenting or detailed pictures of the existing situations or trends. Okay, what and all it includes means it includes the comparative correlational methods and fact-finding inquiries. It focuses on presenting or detailed picture of existing situation or trend. Example, a study on the traffic patterns of the city detailing the current state of congestion in various areas without attempting to control the focus contributing to the congestion. Okay, next one is analytical research. This is for analyzing. Okay, to critically analyze. So to critically analyze and evaluate existing data, looking for patterns, relationships, or underlying causes. It uses already available facts for in-depth analysis. The researcher evaluates and interprets data rather than just presenting it. Okay, it uses already available facts for in-depth. Okay, now for in-depth analysis, the researcher evaluates and interprets data rather than just presenting it. Example, analyzing the correlation. Okay, now it analyzing the correlationship between temperature and the strength materials used in construction. Now applied versus fundamental research. Applied research is what? To solve a specific immediate problems and address practical issues. Applied research is action oriented and seeks practical solutions that can be implemented right away. Okay, applied research means to solve specific immediate problems. Okay, to solve specific immediate problems, we will use applied research. Okay, it is applied research is action oriented and seeks practical solution that can be implemented right away. Example is developing a new material to improve the energy efficiency of solar panels. Okay, fundamental research means to expand the knowledge, theories, or understanding of fundamental principles without immediate practical application. Okay, this is like theories. Okay, to expand knowledge, theories, and understanding the fundamental principles without immediate practical application. This is only for theory. It focuses on generating theories or understanding underlying concepts and phenomena. Example, the studying of properties of atomic particles to develop new theoretical physics models. Next one is quantitative versus qualitative research. Quantitative research was to gather the numerical data. Okay, quantitative, that is quantitative, no, numeric data, to gather the numeric data and apply statistical analysis to draw conclusion about the trends, relationships, or patterns. It involves large sample sizes of the collection of numerical data that can be statistically analyzed. Example, measuring the compressive strength of various types of concrete, of comparing the results statistically. Okay, quantitative is related to numerical data and applying statistically. Okay, in qualitative means to understand the phenomena in depth. You cannot to understanding the phenomena in depth by exploring non-numerical data. Okay, now by exploring non-numerical data like experiences, behaviors, or perceptions. Okay, by exploring non-numerical data, that is quantitative is numerical data, qualitative is non-numerical data. Okay, often involves smaller sample size of and uses methods such as interviews, case studies, or observational techniques. Okay, now case studies or observational techniques. Example, observing traffic flow at the intersection and interviewing drivers to understand their behavior during peak hours. The last type is conceptual versus empirical research. Conceptual means to explore the abstract ideas or theories and develop new concepts or reinterpret existing ones. It involves thinking, theorizing, and developing models without direct experimentation or data collection. Examples, theorizing new approaches to sustainable engineering based on the concept of energy efficiency. Okay, conceptual means same, it explore ideas, theories, and develop new concept, reinterpret existing ones. Example, theorizing new approach to sustainable engineering based on the concepts of energy efficiency. Empirical research means to gather and analyze data based on observation or experience, often through experiments. Empirical research is data driven and focuses on verifying hypotheses or theories through direct observation or experimentation. Okay, now empirical research means to gather and analyze data based on observation or experience, often through experiments. Empirical research is data driven and focuses on verifying hypotheses or theories through direct observation or experiment. Now next question is explain research flow cycle with neat diagram. Okay, there are 11 processes. First one is formulating the research problem. Formulating research problem means it is the starting point of any research. The research identifies a specific problem or the area to explore. A well-defined problem ensures focused and meaningful research. Okay, well-defined problem, it ensures focused and meaningful research. Next is extensive literature survey. Once the problem is clear, review existing work in the area. This involves studying research papers, books, articles, and technical reports. It helps identify what is already known and what gaps exist in current knowledge. Okay, formulating a research problem, we should do literature survey. Okay, once the problem is clear, review existing work in the area. This involves studying research papers, books, articles, and technical reports. It helps identify what is already known and what gaps exist in current knowledge. Next, development of working hypothesis. Hypothesis means assumptions. Okay, It is a guess or assumption made to test its validity. It guides the research and focuses on specific aspects of the problem. Hypothesis should be testable and relevant to the problem. Next is preparing the research design. We should prepare the design. Okay. Research design is the framework or the plan for conducting the study. It specifies how data to be collected, analyzed, and interpreted. A good design ensures efficient use of time, money, and resource. Next one is determining sample design. After preparing the research design, we should determine the sample design. A sample design is a strategy for selecting units to study. The goal is to ensure the sample represents the population accurately. Okay, now next, collection the data. This involves gathering the necessary information. Okay, now collecting the data means this involves gathering the necessary information for the research. Data can be primary or secondary. Next, execution of the project. This is the actual implementation of the research plan. Okay. It involves conducting experiment or surveys and recording the result. Next, analysis of data. Once data is collected, it needs to be organized and analyzed to draw meaningful conclusion. These steps often involve statistical tools and software. Okay. Then hypothesis testing. After analyzing the data test whether the hypothesis is supported or not. This helps validate the findings. Use statistical tests like chi-square, t-test, or f-test to evaluate the hypothesis. Next, generalization and interpretation. If the hypothesis is validated, the research can generalize findings and develop new theories or recommendations. Last one is the preparation of the report or the thesis. Okay. The final step is to document the entire research process and findings in a clear and structured manner. This is the last step, and you should draw the flow diagram. Okay, it is there in textbook. Next question is, give the detailed description of ethics and ethical practices. Ethics in engineering research. Ethics in engineering research refers to the set of principles that guide acceptable and unacceptable behavior. Okay, it is a set of principles that guide the acceptable and unacceptable behavior. It ensures that research is conducted responsibly, safely, and with respect to individual, society, and the environment. Then ethics is about distinguishing right from wrong, guiding researchers in acceptable conduct. Okay, ethical understanding begins early but evolves over time, and interpretations may differ among individual and culture. Ethics versus laws. Ethics are shared values influencing behavior, while laws enforce rules. Many laws are based on the ethical principles. Okay, ethics versus laws, same thing only. Then we'll write the historical context. Nuremberg Code and then British Royal Society. Okay, 1947, that is Nuremberg Code. It is established international norms for ethical research after World War II. The British Royal Society, that is 17th century, changed credit attribution in science, prioritizing first publication over first discovery. Now we'll see about ethics in engineering research practices. Okay. First one is addressing technological concerns. Ethical decisions are essential in areas like privacy, surveillances, and data handling. Researchers must ensure technology does not harm individuals or society. Next, data ethics. The accessibility of large data sets demands ethical decisions about their use. Some data-driven actions may be technically possible but ethically unacceptable. Okay, technically possible but ethically unacceptable. Some data. Okay. Then the role of researchers, setting ethical requirement at the start, influencing technology, societal effects. Design decisions should prioritize ethical considerations like safety and fairness. Researchers must choose ethically sound alternatively when fulfilling similar goals. Okay, then list the different types of research misconduct, provides examples for it. Research misconduct means it refers to the actions that violate the ethical standards. Okay, these are the actions that violate the ethical standards or accepted practices in conducting, the reporting, or publicizing research. It involves any dishonest or unethical behavior that undermines the integrity of the research process. There are three misconduct. One is fabrication, falsification, and plagiarism. Fabrication means it involves making up data or experimented with the intention to mislead researchers. Okay, to mislead researchers. May create fake data because they believe they know that the result should be, but are under the time pressure to deliver result. Fabrication involves making up data or experimented with the intention to mislead researchers. May create the fake data because they believe they know that the result should be, but are under time pressure to deliver the result. Okay, example is here, researchers create fake survey result to support the hypothesis when no real data was collected. This leads to the misconduct. Next, falsification, like false information they will provide. Okay, falsification occurs when the researcher intentionally manipulates or alters data or experimental result to match the desired outcome, even when the actual data contradicts this. Even if the actual data will not produce the hypothesis, also they will put the different data and they will manipulate, they will do alter, and they will show it will match the desired outcome and it will submit up. See example, changing the measurements of an experiment to make the data fit the expected result, such as altering figures in a graph to mislead reviewers. Next, plagiarism. Plagiarism involves using someone else's ideas. Okay, plagiarism means it involves using someone else's ideas, text, data, figures, or concept without giving proper credit. Okay, without giving proper credit or acknowledgement. This includes both direct copying and reusing one's own previously published work. Okay, this is like someone else report reusing it. Okay, detection. How you detect means like original authors. How you will detect means original authors may notice and report it. Reviewers or editors may catch it during the review process. Example: copying text from another researcher's paper without citation, or reusing one's own previously published work without acknowledging it. Consequence of misconduct: loss of credibility. They may lose their credits, and then a legal and professional consequence: they may lose their jobs. Okay, then damage to research integrity and harm to research participants. These are the consequences. The next is ethical issues related to authorship. Okay, now in where and all they'll get credits, how they will do this and all. Author credits for research contribution. Authorship. Okay, only those who have made significant contribution to the research should be listed as authors. Okay, only who have made significant work for them only they'll give authorship. Citation means acknowledge previous work. Okay, acknowledgement means mention others who provided input without being authors. Problematic authorship practices means guest or gift authorship, listing someone who didn't contribute meaningfully. Okay, career boost authorship means giving co-authorship to someone to help their career. Even with minimal contribution they will get the career boost authorship. Career preservation authorship means adding senior officials as authors in exchange for favors without them contributing. Okay, next, ghost authorship, not listing a significant contributor due to conflicts of interest or internal politics. Third one is unclear or minimal contest and responsibility, accountability of co-stars, double submissions. This and all will, these are related to authorships.